Moving on to example 2. What are the zeros of h of x equals 4x cubed plus 4x squared minus 24x? Notice the difference here. This is not factored. This is a sum and a difference of objects, and there is no sum and difference property of zeros. So in order to be able to do this, my first task would be to factor if at all possible. And factoring is what it has been every time we dealt with factoring. We did binomial factoring most recently. We did trinomial factoring prior to that. The first step of factoring a process of any polynomial, if you look at the entire expression you're looking at, you look for a common factor. Something evenly divides all the numbers, and if there's a common letter, you need to deal with that first by pulling it out. So notice that 4 divides all 3 numbers, so 4 is a common factor numerically. X to the third, x to the second, x to the first, everything contains x. When there's a common letter, the smallest power is what's going to be common. So x to the first is common, x squared and cubed are not common. So 4 is the biggest number that evenly divides all the numbers. X to the first power is the biggest power of x I can be allowed to take out. And once I establish what the common factor is, I'm going to simply divide each term by it. So 4x cubed divided by 4x to the first makes x squared. 4 divided by 4 makes 1. X cubed divided by x, subtract the powers, 3 minus 1 is 2. Do not write the 1 if not necessary. I don't like to write the 1. 4 divided by 4 is 1. X squared divided by x makes x to the first power. 2 minus 1 makes 1. And then negative 24 divided by 4 is negative 6. X divided by x cancels. So we have 4x times x squared plus x minus 6. Once you've done that step, what's left now is a linear term, 4x, times a quadratic term. So now I'm looking to see, can I factor this any further? I'm looking for 2 numbers that both multiply to make negative 6, and they also add to make positive 1. There's officially a positive 1 here, right? Since it's 1x squared, that's all we need. 3 times negative 2 makes negative 6. 3 plus negative 2 makes positive 1, which means this factors to x plus 3 times x minus 2, and then we have our 4x. So I take my expression, whatever it is, and I factor as much as I possibly can using some factoring techniques we've learned so far. Then I apply the zero product property. Factor 1 is 4x. Factor 2 is x plus 3, and factor 3 is x minus 2. Again, it doesn't matter how many factors you have. In this case, I have 3. And I set each factor equal to 0, solve however is necessary to solve it. So 4x equals 0, x plus 3 equals 0, or x minus 2 equals 0. How do I solve 4x equals 0? Divide both sides by 4. What is 0 divided by 4? 0. How do I solve x plus 3 equals 0? Move the 3 and becomes negative 3, right? So that means x equals negative 3. And how do I solve x minus 2 equals 0? Add 2 to the other side, so chop that, put plus 2, x equals positive 2.
So would x equal 0 on the other one?
X equals 0 for that one because we divided by 4, yep. This is a multiplication. We undo that with division. We undo addition with subtraction. We undo subtraction with addition. So each problem, it's just up to you to determine what's happening, how do I solve it. Okay, and it depends on the structure of the problem as far as how you solve it. Okay, so the structure establishes technique. And once we get our answers, that's the end, right? So x equals our answers. So x equals 0, negative 3, and positive 2. So either it's already starting off in factored form, set each factor equal to 0 and you're ready to go, or it's starting off in simplified form. You have to factor it first and then set each factor equal to 0 to solve. If it's asking for the zeros look like this. They do not look like this. All right, they don't want you just to factor, they want you to factor it, then use the factored form to get the actual numerical values that solve the problem. Any one of these numbers, if I put it back in the original problem, for example, if I put 0 in, what's 4 times 0 cubed?
0.
4 times 0 squared?
0.
24 times 0? And 0 plus 0 minus 0 equals 0, right? If I put negative 3 in, this is a little harder to do. Negative 3 cubed is negative 27. Negative 3 squared is positive 9. And negative 24 times negative 3. So this makes negative 108. This makes positive 36. and two negatives make a positive. 24 times 3 is 72. 36 plus 72 is 108. That makes 0. What we're finding is numbers that if we put those numbers into the expression, we're going to get 0 out. So if I tried 2 cubed is 8, so that'd be 4 times 8. 2 squared is 4, that'd be plus 4 times 4. And this is minus 24 times 2. This is 32, this is 16, that's minus 48. 48 minus 48 makes 0. That's what those numbers represent. If you put those numbers into the function, we'll get 0 out of the function. All right? So, that is the first goal for today, is to be able to find the zeros of any polynomial function, whether it starts off in factored form or whether you have to factor it first.